Hello everyone. In this video, I'm going to do the same thing in part 2, but I just wanted to show you a different option besides using the quadratic formula when you have to factor to get the other roots. Alright, just like I said in the previous video, they gave us one of the roots, which is 5. So I use synthetic division to divide and get my quadratic polynomial so I can factor and find the other roots. Alright, so my coefficients are 1, negative 5, 5, and negative 25. Of course, I'll bring down my first term, multiply, add straight down, multiply, add straight down, multiply, add straight down. Of course, my remainder is 0 because x equals 5 is one of the roots. All right, so this will be 1x squared. Since it's 0, I'll skip the x and then plus 5. So like I did in the last video, I would factor x squared plus 5 using the quadratic formula, but I just wanted to show you a different method. This right here is the sum of two squares. So if you remember the identity formulas that you guys previously learned, whenever you have x squared plus y squared, it factors out to be x plus iy times x minus iy. So if I factor this out, it will be, of course, x and x, because when I take the square root of x squared, it equals x. Obviously, the square root of 5 is not a perfect square, so it'll just be I square root of 5 and negative I square root of 5. This is what you guys just previously learned. So the extra step is to set each one of these equal to 0 and solve for x. So if I take x plus I square root of 5, set it equal to 0, all I'm doing is subtracting I square root of 5 on both sides. So my first solution will be negative I square root of 5. All right, let me do my other factor. The one that says x minus I square root of 5. If I set that equal to 0, I'll be adding I square root of 5 to both sides. So therefore, x will equal positive I square root of 5. And of course, the first root that they gave me was x equals 5. So these are my three solutions. And again, I have 3 roots because my highest degree was 3.